Hi folks! Today we're going to talk about composition of functions again. In the last set of notes we talked about how to use composition of functions when you have a table or a graph, but today we're going to talk about composition of functions when we're given equations. So there's a little bit more to learn about today. We're going to learn how to put functions together with a sum, so addition, with a difference, subtraction. We're going to learn how to find the product, so multiply, and the quotient, divide. So we're going to learn all those different ways to compose functions, and then we're going to also talk about nestling functions inside of each other. So we may end up finding f of g of x, or as we learned yesterday, it might be written like this. So we're going to learn how to do all of those things today with equations. So the first thing you need to realize is that from yesterday, we have the symbolic form of what we're doing, and then we have what helps us actually complete the problem. So this is symbolic, f of g of x, but what we're really doing is finding f of g of x. Same thing with these. So if I'm finding the sum of functions, it's going to be listed as f plus g of x. But really what that means is to just take the two functions and add them together. Same thing with subtraction. The symbolic form to write the subtraction of functions is going to be f minus g of x. But what you're going to do is you're going to take a function f of x and subtract from it g of x. The product will be listed as f times g of x, and what you'll do is multiply f of x times g of x. And remember, f of x and g of x are most likely polynomials, so when you multiply them together, you might have to use distributive property or FOIL or something like that. With these two, you'll have to think more about combining like terms. And then lastly, we'll talk about the quotient. So it'll look like f over g of x, but what it will really be is the function f of x over the function g of x. And of course, g of x can't be equal to 0 because we can't divide by 0. We'll get an undefined answer. So we've got 4 examples on the front side. I'm going to be asked to find f plus g of x, f minus g of x, f times g of x, and f over g of x. And my functions are here. So I have the function f of x equals 3x squared minus x plus 5. That's my f function. And then I have g of x equals 2x minus 3. That's my g function. So my f function is quadratic. My g function is linear. So the first thing I'm asked to find is the sum, f plus g of x. So I need to take f of x and g of x and add them together. So f plus g of x equals, I go find f of x. There is no x value, so I'm just rewriting with the actual x's in place, 3x squared minus x plus 5. And I'm adding to it g of x. And the g of x function is 2x minus 3. Now, I'm going to go through and I'm going to combine my like terms so that I can simplify and get a nice polynomial for my answer. Now, my x squared term, there's only one of them there, so 3x squared. My x terms, I have negative x and plus 2x. So negative 1 plus 2 is 1x. And then finally I have plus 5 and minus 3, and 5 minus 3 is 2. So if I'm going to add f plus g of x, then I get 3x squared plus x plus 2. That's my addition of functions. So it's not too bad. It's just the symbolic representation that you have to get past, and then it's just combining like terms. So now, let's look at subtraction. So for subtraction, I want f minus g of x, so I'm just going to subtract the two functions. F minus, see, there I go, writing the wrong thing. F minus g of x equals, I go find my f of x function. So it's 3x squared minus x plus 5. and I'm going to subtract, and I'm subtracting a whole function. So instead of filling this in with just 2x minus 3, I need to make sure that I subtract the whole thing. So instead of just subtracting the 2x, I also have to subtract the what? The minus 3. So when I do that, pardon the extra pieces of writing here. When I do that, I'll have 3x squared minus x plus 5, but then I'll have minus 2x and minus negative 3, so that's really plus 3. And I can combine my like terms to get a simplified polynomial for f minus g of x. So I only have one x squared term, that's 3x squared. I have minus x minus 2x, so negative 1 minus 2 more is minus 3x. And then I have plus 5 plus 3, so that's plus 8. And this is my subtraction of f minus g. All right, so far not too bad. As long as you can get past the symbolic representation, then you can combine your like terms and get the final polynomial. Now let's look at the next one, which is multiplication. It says that I'm going to have to find the product f times g of x, which really just means I need to multiply the two polynomials. So when I do that, f of x times g of x, I go find f of x, which is 3x squared minus x, not plus, minus, plus 5, and I need to multiply it, the whole thing, by the g function, which is 2x minus 3. Let me go ahead and keep my colors consistent here. For g of x, I've been using pink, 2x minus 3. So when I multiply these together, I'm going to have to either use distributive property or I can use box method, and either one is absolutely okay. I'll set up box method for you, but then I'm going to do distributive method. That way you get assistance in both of those formats. So for box method, I have a trinomial times a binomial, so that means that I need two sides here and 1, 2, 3 up here. This is 3x squared minus 1x plus 5, and this is 2x minus 3. So you can go ahead and fill in your box method here if you'd like to. I am going to find f times g of x by doing distributive property. So 3x squared times 2x is 6x cubed. 3x squared times negative 3 is negative 9x squared. Next term, negative x times 2x is negative 2x squared. Negative x times negative 3 is plus 3x. Next term, 5 times 2x is 10x. 5 times negative 3 is negative 15. And I can combine my like terms to find f times g of x. So there's only one x cubed term. That'll make an appearance in my answer. For x squareds, I have negative 9x squared minus 2 more x squared, so that's minus 11x squared. I've got 3x plus 10x, that's 13x, and then I have my minus 15 for the constant. So this would be f times g of x. And finally, we have division. So when you divide f over g of x, you're really taking f of x and putting it over g of x. So f over g of x. F of x goes on top because f is on top here. So 3x squared minus x plus 5. And g of x goes on the bottom, 2x minus 3. Now, if I could factor the top, then I might want to try. That way, if one of my factors was 2x minus 3, I could cancel it out on top and bottom. But I happen to know that there is no nice factorization of f of x. So I'm going to leave it like it is, and that's it. So this is the way that you would compose functions, f of x and g of x, with addition, subtraction, multiplication, and division, all of the main operators that we use in algebra. Now, if I move to the next page, the next page is about composition of functions and nestling functions inside of each other. You always want to work from the right side to the left side because what that means is you're working from inside to outside. So this is kind of like inside to outside. So, in the last set of notes, we talked about how f of g of 2 is really written as f parentheses g parentheses 2. So you always start from the inside. Notice that I have my, let me get a different pen here. There we go. So notice that we have f of x. It's different in this problem. F of x is x squared minus 2x minus 3. We have g of x, which is linear. It's 3x plus 4. And then we have h of x, which is also linear, and it's just equal to x minus 2. So I kind of have my colors coordinated here. I'm going to find f of g of 2. Well, first thing I need to find is g of 2, right? So I need to work from the inside out. G of 2. That means 2 in parentheses is my x value, and I'm going to use the g function. So in the g function, g of 2 would be 3 times 2 plus 4. 3 times 2 plus 4. 3 times 2 is 6. 6 plus 4 is 10. So g of 2 equals 10. Now, I need to find f of 10. So I'm going to use an x value of 10 in my f function. F of 10 equals 10 squared minus 2 times 10 minus 3. F of 10 equals 10 squared is 100. 2 times 10 is 20, and then minus 3. 100 minus 20 is 80, and 80 minus 3 is 77. So I can say that f of g of 2 equals 77. Okay. So now let's try the next one. The next one asks you to find 3 times g of f of negative 2. So again, we work from the inside out. So the inside is f of negative 2. So that means I'm using this function. I have negative 2 squared minus 2 times negative 2 minus 3. Negative 2 squared is 4. Negative 2 times negative 2 is plus 4. That's 8. And then minus 3 is 5. So now I'm finding g of 5. So g of 5 is 3 times 5 plus 4. 3 times 5 plus 4. 3 times 5 is 15. 15 plus 4 is 19. And now in the end, I want 3 times everything, which was 19. And 3 times 19 is 57. And no, I don't know the math that quickly. I just have the answers in front of me. So 19 times 3, if you wanted to do it in the calculator or off to the side, you would get 57. So remember to work from the right side to the left side or inside to outside. Now, number 6 is slightly different. Number 6 asks for f of g of x. It does not give you an x value. It's asking for an expression with x in the expression. So even though x typically is like a number, here it's just a variable. So that means it's going to be a variable in our answer as well. So we need to nestle g of x inside of the f function. So I'm going to go ahead and I'm going to write the f function, but I'm going to leave a bunch of space where x is, because x is supposed to be this whole g of x piece. So f of g of x is equal to x squared minus 2 times x minus 3. Now that x piece is g of x, and g of x is 3x plus 4. So notice now that I have nestled g of x in place of x in the f function. So now I need to work from the inside out. I know that 3x plus 4 squared means that I need to FOIL 3x plus 4. So I'm going to go ahead and do that out to the side. 3x plus 4 times 3x plus 4. Just to get it out of the way. 3x times 3x is 9x squared. 3x times 4 is plus 12x. This is another plus 12x. And 4 times 4 is 16. These two make 24x. So whenever I FOIL this, I have 9x squared plus 24x plus 16, because that's what I got when I squared 3x plus 4. I'm going to distribute this negative 2 to 3x, so minus 6x. And negative 2 times 4, that's minus 8. And then the minus 3 at the end. This is f of g of x. So when I combine to get some like terms and get my final polynomial, I only have one x squared term, so 9x squared. I have 24x and minus 6x, so 24x's minus 6x's is 18x's. Then I have 16 minus 8, which is 8, minus 3 more, which is 5. So f of g of x is 9x squared plus 18x plus 5. Keep in mind that if x is in your problem, x will also be in your answer. So now that you've had a little bit of practice with composing functions inside of one another, I want you to try this one. This one is really g of f of x, meaning we're putting f of x inside of the g function. So go write the g function with a big space for x, and think about what goes here. What are we using for x in the g function? We're using f of x. So this x squared minus 2x minus 3 is going to go here. Pause your video and try, Pause your video and try to find g of f of x, the final polynomial. So check your answer with mine on number 7. You distribute the 3 to all 3 terms of the f function, and then you combine your like terms. Negative 9 plus 4 is the negative 5 you see here for a constant. Let's try number 8. Number 8, you're trying to find g of h of f of x. Holy smokes. Well, the inside is f of x. And you're going to put f of x inside of the h function. And that in turn is going to go inside of the g function. All right. So let's start out with f of x inside of the h function. So the h function is x minus 2. So I'm going to take x minus 2. And the thing that I'm using for my x in the h function is the function f of x. X squared minus 2x minus 3. So here is h of f of x. But all of this needs to be used as my x in the g function. So my g function is 3x plus 4. So I'm going to multiply 3 times my x that I'm using, and then plus 4. So notice how we have f of x inside of h of x inside of g of x, which is what we want. F inside h inside g. So I'm going to use PEMDAS to kind of evaluate this. Inside x squared minus 2x minus 3 minus 2 is really x squared minus 2x minus 5, because these two together make minus 5. Next step is to distribute the 3 to each term here. So we have 3x squared minus 6x minus 15, and we have the plus 4. And then finally, negative 15 plus 4 will give us 3x squared minus 6x minus 11. And this is the composition g of h of f of x. So notice we have the f function inside the h function inside the g function, just like it lists here. So problems 9 and 10 are a little hectic. So I'm going to show you how to do them, but I want you to try them out, and I'm going to write all of my work here so that I can walk you through it and you can see everything at once. So pause your video, try to get as far as you can, and then you can come back on and you can see all of my work. Okay. So this problem is not as difficult as it seems at first, because I noticed that instead of x's, I have numbers, which is great. So I can do this part first, and I can do this part second, and then I can put it together, 2 times this minus this. So first thing I notice is I'm finding h of 3. Well, h of 3 is 1. And then I'm using that to find f of 1. Well, f of 1 ends up being negative 4. So that's my first piece right here, is negative 4. Now I move on to this one. I'm originally finding f of negative 4. Well, f of negative 4 is 21. And then I'm finding h of 21, and h of 21 is 19. So I put this together and I do 2 times negative 4 minus 19. Negative 4 minus 19 is negative 23, and 2 times negative 23 is negative 46. So this is number 9. Number 10, I did not evaluate, well, not evaluate, I did not make it a nice, pretty polynomial, because I wanted to break it down to show you exactly how I put this together. Now this is what it looks like. Now obviously I could do some simplifying and I could make this into a polynomial, but I really want you to see what it looks like, because number 10 is just crazy. It's a function inside of a function inside of a function inside of the original function again. So it's like 4 different layers. So what I did is I took the h function that's x minus 2, and instead of x, I just put a big set of parentheses. So this is the green, something minus 2. Now inside that something, as the x that I'm using is the f function right inside. So I took x squared minus 2x minus 3 and I put that inside. X squared minus 2x minus 3. Remembering that anytime I have x, I use big parentheses because I'm inserting another function in there. So inside of the f of x function, I'm using the g function, 3x plus 4. So inside these parentheses, I put 3x plus 4. And inside these parentheses, I have 3x plus 4. And finally, inside of the g function, I have the h of x function, which is x minus 2 again. So inside these parentheses, I have x minus 2. Inside these parentheses, I have x minus 2. And if you take all of this and you kind of collapse it up, you end up with this right here. So I just wanted to show you the crazy example. You're not going to have a lot of problems like this, but it's nice to know what to do when you encounter a problem like this. So overall today, you learned how to use composition of functions with equations. You learned how to find the sum, difference, product, and quotient. And then you also learned how to compose functions using g of f of x and f of g of x, and you even extended it to include a third function.